For this tutorial, we log into the cluster shell of our cluster and we're going to create an aggregate. We are logged in and set the row size to 0. This gives a more readable output. You don't have to do this, but I prefer to do this. Then we go to advanced mode because we want to make sure that we will not be bothered about not being able to execute some commands, maybe. We also don't have to do this, but it saves time in many cases. There's a warning, but we will be very careful. Let's list our cluster and see that we have 2 nodes. Then we check our aggregates and we see we only have 2 root aggregates, 1 per node. These 2 aggregates hold the root volume of the node. These aggregates cannot contain any user data, so we need at least 1 data aggregate, preferably 1 per node, but we're going to create one for 1 single node. Let's first check our available disks for node 1 of our cluster, because that's the one that's going to get the aggregate. We get a listing of all of our disks, so we see spares at the bottom, we see spares at the top, and we also have 4 disks that are in the root aggregate of node 1. And if we just want to list our spares, we use the container type option and specify spares for node 1. This gives us a total of 24 spares. Now let's create the aggregate. It will only get 6 disks and the RAID group size will also be 6. So the aggregate will be created for node 1. This will give us a single RAID group of 6 disks, 4 data disks and 2 parity disks. We check the RAID groups and see that we have RAID group 0 as the only RAID group in our aggregate. Now we change the max RAID size to 10, so we add new disks to the aggregate, and we decide to first fill out the existing RAID group to 10 and then add the remaining disks to the new RAID group. It's important to know how many disks go into one single RAID group before you grow an aggregate. So in our case that will be a maximum of 10 disks for one single RAID group. Now if we add 14 disks to our aggregate, it will fill out RAID group 0 to 10 by adding 4 disks to that RAID group, and then create a second RAID group of the remaining 10 disks. So we'll have 2 equally sized RAID groups. Now when we list the RAID groups again, we see that we have RAID group 0 and RAID group 1. And we can check which drives belong to which RAID group by filtering the RAID group field in disk show. It's what we expected. 10 disks per RAID group. Finally, we will offline the aggregate. We delete it. And we zero the spare disks. You can check how the zeroing progresses by filtering zeroing %. Depending on the size of your disk, this may take a long time. We have 1 GB disks, so that's done in a few seconds. And the dash in the zeroing % column means that either the zeroing has not started yet or it is finished. Well, in this case, the zeroing is finished. And we're back to where we started, no data aggregates, and we're done.